All right, as we have a lot of content to cover, I'm going to begin. Just want to do another audio check, make sure everyone can hear me okay. We have a growing number of attendees. How's this? Thanks, everyone. All right. So we're going to begin. So why am I giving this presentation? Well, honestly, I wasn't a big kind of Bitcoin believer back in the day, but over the years, owning a couple companies, doing a couple startups, I've learned to look at technology in a unique way, and I think blockchain has a very disruptive core to it. You have to separate Bitcoin and blockchain. And by the end of this kind of discussion and this discovery, I think you're going to understand all the values that blockchain has. My core kind of area of expertise in management consulting, changing organizations, upwards of $6 billion budgets. And so when I speak for a broader audience. I speak for the massive enterprises, as well as the startups. I've owned a few, I manage a few, and I also come from a blockchain arena many people may not know about mining. I advise people on setting up mining farms and establishing that mining because it's residual income, and it's pretty good for a lot of people. So I've had my hands all over blockchain, different parts, and I've learned quite a bit, and they asked me to speak about it. I think you guys are going to learn quite a bit. So let's jump in. And again, some of the ground rules here. We have muted all of you. It's just more of, there's going to be hundreds of people on here, so we can't really have everyone chat. I have labeled all the slides. You should see the slide number. Are you speaking? I can't hear anything. I did do an audio check.
Yes, we can hear you. No problem.
Thank you. Okay, sorry. Great, cool. Sounds good. Thanks, guys. I'll look for that feedback. I labeled all the slides, slide 2, and there's a lot to cover. I've given this presentation already about 5 or 6 times. I cover a lot, and I probably even cover your question. And so if you have a question, just put the slide number on, state the question, and we'll try to cover them at the end and see if we still need to cover it. That way we can get through it. This is about a 45-minute run. I am going to condense weeks of knowledge of blockchain to you, weeks, all right? And so it's going to be a fast run. And so I'm excited, and I think we're just going to dive right in. Start going here. So the first thing I need to describe is blockchain. It's big. It's bigger than anything I've seen. It's bigger than what I'm going to tell you. All right, it's to give you an idea for those people like me that are a little dated. If you could think back to 1995, prior to all the dot-com chaos that ensued over the next couple years, we are about exactly where that was, but for blockchain. There's a disruption coming, and you either are with it or not. And I think it's very, very big, and there's a lot of areas to focus on. You do not need to be on finance. You can be on data. You can be on certain areas of blockchain. Pick your area, and I think you can excel at blockchain and take this ride that's going to happen over the next 5 years with it. And so everyone's kind of shocked when I tell people there's over 850 different crypto coins. I like using this term. It's instead of just saying, Bitcoin is the only thing, there's way more than Bitcoin. Bitcoin is the incumbent leader. It owns a significant portion of the, the market cap. At times it's about 50%, it could be more, it fluctuates daily. But behind the scenes, there's thousands of other crypto coins that exist. Some have gone completely away, and some are just starting up. And so this area of blockchain, when I look at it from a macro level. There are certain types of blockchain solutions out there. The ones I'm showing, the 850, are the only ones that actually have value. And there's other ones that are coming online daily through something called an ICO, an initial coin offering. I've done some ICO audits, and so it's very interesting to see that change, and that is a very disruptive field. But just to give you an idea of how volatile, how changing this market is, the market cap at the time I took this, and I'll put a stamp on here, this market changes rapidly. So everything I'm giving you right now is probably as good to August and September, and then a couple weeks out things could change. but the market cap was $171 billion, all right? It grew 90 billion in less than 30 days. That's like a couple, was it Ubers and a couple, Airbnbs, all right? That's the market sway, that's the volatility, and so there's quite a bit. How many blockchains does the future hold? I do think there's going to be a shrinking. I do think that, you know, we're looking at a lot of competition. I've been trying to get into this transaction flow. Yes, you will be getting a copy of all the slides because there's a lot of data. I'm cramming it in. You'll see that there's 3 different sections. I like this style. On the left, you see the introduction. On the bottom is a news blurb. All right, I don't always cover those, but I like to put reality check into what we're doing. This isn't just all theoretical. There's a lot going on, and so every now and again, I might talk to those little news blurbs. All right, so let's move forward. For those people that have never seen a blockchain transaction, never done it, it's quite difficult. Some people even give up, saying this is only for techies. I say that the challenges are there, but they're getting much better, and it's simplified with these UI type wallets. All right, and so let's kind of walk through this. All right, a wallet, for many people that aren't blockchain savvy yet, is simply your address. And when you get one, you do not need to tell the world who you are. You simply download their blockchain app, and as soon as you activate it, it's probably going to ask you to provide a password. All right, that is the very unique secret password that unlocks access to funds and access to that wallet. All right, if you lose that password as well as the file that they're going to generate, you no longer have access to the funds, and there's no way of getting that back. All right, so you download a simple app to get a wallet. Let's say you want to send some money to your friend. You're going to get their wallet or their address. All right, you're going to select how much money, and you're going to enter that password and hit send, and that's it. It's seconds. And that could be $10. That could be, you know, $10,000. It really doesn't matter on the amount of money. It's so simple and it's so easy. And the transaction fees associated are laughable. You know, they're so low that you just wonder how banks are going to be around. You know, if I were to tell you that it's going to be, you know, a couple pennies to transfer money versus going to your local bank, and I can send this money anywhere in the world. It's very, very disruptive when it comes to that. But once you send that on, it enters this world of machines. Machines have 2 parts. There's the nodes, all right? A node, quickly described, we'll go over it in more detail. A node holds the entire database and or word ledger of all transactions on the blockchain, all right? They hold everything, all right? Now, just jumping over to miners, miners help verify the transactions, all right, and improve the data quality, all right? They are the mathematical computational power behind blockchain, and they are rewarded, all right, with actual new coins. In many cases, the only way new coins are generated are through miners. And so they don't just go and print 1 million new coins just because they want to. It's established governance up front that the miners, as they mine, are rewarded brand new coins, and that's how we introduce new coins into the market. So now that we have nodes and miners kind of like quickly described, let's go through this. As soon as I sent my money, all right, it didn't actually go to the person I was sending it. It had to obviously get onto a node as a transaction. That transaction gets entered into a block that we're currently in. The miner pulls in those transactions. The miners then validate the transaction through something known as cryptology and hashing algorithms, which we'll cover. I'm just doing it at a high level now. The first miner to solve this very complex problem is rewarded with new coins. Other miners and nodes verify their work, and the transaction's complete. Now, that might have seemed, you know, a little bit different. Behind the scenes, the machine side you don't really see. But the question is, how long did that take? And it can take a little while. It's not sub-second response. We can talk minutes here. This can take 9 minutes from the time I hit send and when it gets there, and it's got to go and do all this other stuff. If you want to pay more, you can speed it up. And so that's a typical blockchain transaction lifecycle, all right? Now let's go into the next slide. Now, rapid history of blockchain, if you didn't know that already, let's do this. I threw it in because I think everyone needs to kind of just get an idea. How long has it been around? How long has Bitcoin been around? 2008, this guy, Satoshi Nakamoto, created a white paper about Bitcoin. It was perfect timing. The whole financial industry was crashing. Governments were saving it. No one's going to jail. Everyone that's losing their money in their house is pissed, but, you know, what can we do? And introduced this new peer-to-peer transfer of money that was very traceable, auditable, public, all right, and allowed you to sidestep financial institutions. There's no wonder why it took off, all right? Obviously, it didn't take off to be $1 billion right off the bat. It's been going on for years. They've had problems, but it is the, you know, the Genesis blockchain solution, and we're moving it along, you know. I think by 2013, they found out that, you know, the blockchain solution could do more than just transfer funds. And that's where Vitalik Buterin, a 23-year-old, that's how old he is right now, I think, he extended the concept of Bitcoin to create something called a smart contract. Effectively, what it is it's something that lives on the blockchain all the time, and it can run and create simple instructions that move stuff back and forth. And he stumbled on something that's very powerful. He effectively is now utilizing all the power of all the nodes and miners, all right? And we can establish something really cool there. We have this huge grid of computing power, all right? And the way that we utilize the smart contracts is we pay our fair share. It's called gas, which we'll cover, all right? I think there's a great number of innovations. Here we're down in the news blurb here. That 6 blockchain innovations that will affect you. I think everyone's going to find that we have a new way of storing digital assets online. I think blockchain is going to do that. How we manage our identity is going to be hugely disruptive. How we transfer money is going to be so fluid. I don't know if we're going to put our mobile phones down. And I'll cover some of the others, but there's just an awful lot to cover, and I think those are some. I think how you borrow and lend money, this one's going to be very interesting. I think blockchain allows us to lend money to your friend and gain interest in a very trustworthy way. Not saying it's foolproof, but it offers some very unique, very new, cutting-edge solutions that I think is pretty exciting. Okay, so for those people that have not ever been around for rapid cryptology baseline, I'm just giving you kind of like, when I say hashing or hash code or hashing or any power, if it just comes up, I had to describe this, all right? And so if we have a hash method, hello world, and then forget the algorithms. I'm really not getting too technical in this webinar, but all it does is it produces, all right, a unique code, all right? And you can see that code beneath. And if we were to just add another space, a bang, an exclamation point to that hello world, we can see that it changes. But here's the key. It changes in a non-predictable way. You can't reverse engineer that, all right? And we can hash a document, a JPEG, and have the same unique identifier across machines. It doesn't matter who called this. If I take the hash and I take the algorithm and I do it, someone does it from around the world, we all get the same answer. And that's key to how this whole thing works. It's how miners, it's the fundamental thing miners are doing. They're hashing. And how fast are they hashing? Very fast, all right? So I don't even know the number, I'll be honest. So if you look off to the left, all right, 1 TH is a trillion hashes, or a terahash, all right? If you look at Bitcoin right now, that's 8 million. All right, and then you have to do the trillions, because I didn't honestly know the number. I just thought I'd represent it in million. 8 million trillion megahashes a second. All right, we're in a number I didn't even know. You know, I could have Googled it, but I just thought it's just insane, because terahashes is really the standard. That's the highest level we're using. Ethereum is 98 and growing, and they shrink and they grow. All right. And so, cool, that's it for like the cryptology session. But just so you know, we can hash things. We can hash documents, Excel, spreadsheets, all right, and get a unique identifier, and use that as a representation of that uniqueness, and then compare it offline or on to determine its state on the blockchain. I created this. You might not see this anywhere, but there's so much information. When I saw this, I figured I'd throw an acronym in there. It helps me, and so I thought it might help you. So the functions of a blockchain. How can we break down blockchain 2.0, or what are the things? All right, so I put in this dots. All right, so from the standpoint of a dot, it's a decentralized database. If people start using, oh, it's a distributed ledger or it's a ledger, I feel that's the older way of thinking. We're starting to move away from ledger talk and we're start thinking of database, because everyone knows that a database can store any amount of information, and we can store not just financial stuff, but store events and actions on the database. And I think that's the more mature way of thinking it. All right, it still obviously is an accounting ledger, but think decentralized database. Open source, obviously trusted service layer we'll talk about, that may not jump off the page, and a service marketplace. Where can I see my blockchain actions and whatnot? So let's start diving through some of these areas. The first one is a decentralized database. All right, I'm assuming a lot of people have seen this. It's not new, but for those people that haven't, we're just baselining it for everyone. We have a picture, if you can see it, of a centralized model. Obviously, the key problem there is if we take out the center, everything kind of can't talk amongst itself, and so it's a single point of failure. We have decentralized, all right, which is what the blockchain represents, and then we have distributed. And there's pros and cons for all of these, all right? I'm not going to describe the pros and cons, but we take a decentralized model. Why? Because we can have that linking that blockchain always be online. It just needs one node for it to be active, all right? And then from that one node, we can create as many other nodes as we want. And so with one node, it's still up, all right? And so that's part of the coolness. Now, down below, we have this kind of nice little color graph of Genesis blocks and all this. This is the concept of blockchain. I like this. I think this kind of describes how they're all linked if you don't get it. But when a blockchain comes online for the first time, there's really no information. So they call this a Genesis block, block 0. And if you can kind of think about those 3 different sections, all right? So I don't want to use the mouse because it gets too kind of wiggly. But at the top, we have block, header, and then transactions, all right? A header, all right, is effectively the hashing address, the address of the block, all right? We're going to use that cryptology thing. We're going to take all that information. We're going to say, here's the address, all right? And then inside the transactions themselves, that's where all that stuff happens. That's where we're moving money from, Corey to my wife, or, Corey to the kids, all right? All the transactions exist in there. When we're done, all right, and the nodes agree and the miners agree, we complete a block and we increment it, all right? And then we take the previous header, all right, and we use that within all of the, the blocking and hashing and all this stuff. So we cryptology, I'll read that in a second. And then we take the new transactions, the miners evaluate those transactions, come up with a solution, validate it, and lock it down and create a new block. All right, we're going to go through a very good how to buy a house that kind of shows you what are a little bit more detail, but this linking of blocks is all it is, all right? And I think you can escape some of the more, the block, hash, timestamp mounts. It's taken care of for you. And so I just wanted to show some detail. I thought that picture was good. Open source. Everyone loves open source and blockchain. They seem to have a great relationship together. Obviously, blockchain wants things to be hugely transparent. They want to get away from this hidden centralized banking structure. And so by using transparency as a core thing, Ethereum's public, and they want everything to be, basically public that's put onto the blockchain. Obviously, that decentralized nature, it eliminates the central authority, but there are some concerns with the mining pools that are out there. For many people that don't understand mining pools, if that's of interest, we can talk about it at the end. Efficiency. We all love open source because we can use developers from around the world to solve problems and try to hopefully create reusable frameworks and not the same thing over and over. And they've done some really stellar jobs at creating a lot of the blockchain solutions out there. And they've done it from an open source around the world, kind of like not get paid, just work on the code sort of a ability. And the cost of these things, using them, is so cheap. All right. And in the news here, the US just launched a blockchain pilot to digitize birth certificates. That's right. The US is still looking at blockchain. They're not ignoring it. I believe this resides in Illinois. I don't know to the size and scope of it, but that's pretty impressive that they're jumping on. And there's a lot that you see in the news, and we'll talk about regulatory concerns and whatnot later. but it's nice to see that they're taking on some of the low-hanging fruit. Now, the trust service layer, all right? You might hear this. It's called a consensus model. There are three. There's more than three, truth be told. People are creating new ones. But these are the three predominant ones that you would need, all right? What is a consensus model? It's that part of that blockchain transaction flow when the miner agreed and the node's validated, all that relationship that's happening between the miner and the node is typically what's called a consensus model, all right? And one of the most early versions of this, Bitcoin and Ethereum, use proof of work, although Ethereum's going to be moving to proof of stake soon. And so what is proof of work? It's the miner's ability to look at the transaction and all the transactions coming in from a new block, running through those computational powers, solving the complex hash code. And get this, they solve it so quickly, all right? So quickly. I mean, we talked that number. I couldn't even explain. Millions of trillions, right? So quickly that they can actually put in what's known as difficulty. And imagine, because I have that computational power, I can say that, I want you to solve this, and I want to introduce a value every time that you're computing this thing. So that way, when you get an answer, I want you to have a hash code that just happens to start with 10 zeros, all right? You would be able to produce that in any reliable way. You'd have to run every computation. It could happen up front, it could happen in the end, but having that, that trillions of seconds, you could run through all those computations very fast. And through the use of computational power, hashing, and adding ultimately what's called as difficulty, all right, we can solve that problem in a very reliable, time-sensitive way. If we want to solve it every 20 seconds, every minute, 2 minutes, we can increase the difficulty. And so it's based on a linear algorithm of how much computational power does it take to typically get there. All right, and as a reward for solving that, obviously the proof of block rewards the one person that solved that particular hashing problem, giving them new coins. Now, proof of stake, everything about proof of stake is similar to proof of work. But the key here is that they're using account balances. It's very used. They're gonna virtualize certain agreements in the mining, but I don't even know how they're gonna Ethereum and proof of service and proof of work. I kind of think it's gonna be a hybrid. But the core behind proof of stake is that the account balances are locked. That allows you a percentage stake in that blockchain's opinion, all right, of whether or not we should trust transactions and validate them, all right? And that's what's happening. And they're saying that they can do this, all right, at a much greater, scale and save the cost of how much computational power there is. Now, many of you have seen the picture down below. That is only Bitcoin, and that is only the nodes, all right? Traditionally, the scale for nodes to miners might be 10 times more than that. I don't know. It could be 100 times. I know that China's just going to have a bunch, and I don't see a lot. And so the computational power that's out there is massive, all right? I heard a statistic that Bitcoin, all right, all of the miners and possibly the nodes combined equal the amount of energy that Ireland needs, the whole country, all right? So it's a lot of power, and so I can see why they're trying to shift away from proof of service, but I don't like the centralized notion of an account balance. I mean, it looks like it gets centralized really fast. And then there's this wonderful new thing called proof of space. Same thing before, but now we're going to use storage. And so through blockchain and how it's distributed or peer-to-peer, we can now share disk space. I can actually get paid for sharing 100 gigs of a laptop that I have on all the time. Okay, they'll pay you for it, and they're going to pay you half the going rate of what Amazon and Azure and everyone else is doing it. So there you go. You want to get paid? It's very simple. Set it up in 1 minute, And so I thought that was going to be a quick overview of what's going on. And I love this little news blurb. We haven't really gotten to the technical side too much, but imagine these smart contracts, and I'll show you an example of one shortly, are contractually binding. All right, I love this because anyone that's bought a phone recently, it takes like 2 hours to get a phone. And just, it's a simple contract. I want a phone, I have money, I had a phone, I want you to give me a new phone, but somehow it just takes forever. And you know, the future of blockchain, if we can establish a smart contract, maybe a legal contract that exists on the blockchain that knows who I am, what I want, and I simply agree to those terms, all right, we can do away with a lot of nuisance when it comes to certain types of contractuals. And I think cell phones are due, all right? It should not take longer to buy a cell phone than it is a car. It just shouldn't. So let's go on to the next one. What do we got? This is a nice picture. I did not create it, but it shows you that blockchain is used in a variety of space. And I encourage you to take a look at these, all right? Some are still here, and there's great examples all around the place, all right? And I'm gonna jump right to this news blurb, because this made headline news. This was a little while ago. Deloitte made a Twitter announcement around the world saying by 2025, 10% of the global GDP will be stored on the blockchain. That's a powerful statement. That's trillions of dollars. So the leaders online, the architects online, and the tech people online, I encourage you, there is a huge amount, all right, of need to store certain things on the blockchain, all right? And I believe this number is just hitting the tip of the iceberg when we start seeing the usefulness of blockchain. And once it matures a little bit more, I think we will see. I'll answer the slide 9 question at the end, just to keep time. These are the battlegrounds. If you could look at it, starting in the top left, network, infrastructure, and API. Everyone has probably heard of Ethereum, comes second to Bitcoin, and they are, you know, paving the way for creating this. I think the infrastructure play, a blockchain infrastructure, is a right term for this. All right, creating APIs, and there's not alone. There's tons of them. There's private, public, and there's other ones that, you know, just, I don't know, there's just a plethora of them. Do I know every single one of these? No, I don't claim to be an expert in all of them. Do I know Ethereum? Do I know Bitcoin? Do I know some of these? Yes, because they're players. Their ICOs are very hot. When it comes to digital identity, we touch on this. All right, digital identity and how you're going to use the internet. All right, imagine if you never had to put in a password again on any site across your mobile phone or website. That is a near-term future, all right, that could exist, all right? They're trying for it right now, and other companies are getting on board, all right? Control of all of your data, this data that's stored by Facebook, by LinkedIn, but all the companies, Google, all right? What if you could somehow say, I want my data, I want control to it. You can't use it without paying me, without allowing certain benefits or uses. And so that power play on digital identity is huge, it's battleground. Trading platforms and currency exchanges. If you haven't read anything in the news lately, there is a crap load of people fighting for this, being able to obviously trade on the cryptocurrencies, establish funding for ICOs. There's a lot, and so those are some of the kind of the more hotter topics. I don't want to definitely downplay any of the others, but those are definitely the ones that I see as hot. And so that's kind of a cool service market layer view of a whole bunch of different plays. You might have just opened up your eyes to, wow, where can I use blockchain? So this is the only code I'm going to show you, and I just wanted to use it as a representational thing. This is Solidity, all right? This is your typical hello world. All right, cool. You could go to the online compiler, throw this code in, hit go, and you would have something running on the blockchain. In this case, it would be the test net, which is like the test side of blockchain. We can have it up in seconds, and I can call this function. I can go back and forth, and it's great. I encourage anyone wanting to get into Solidity. It's going to be a hot, in-demand tech, and if you're looking for people, this is the people that you probably want to get, because this is where most people are going. So let's kind of understand what's going on. So I just kind of shrank that whole code of Solidity. What happens when I want to create a smart contract? It's very similar to how I move funds, all right? It's just a desired change right at the end, all right? And so I don't necessarily need to send it anywhere. I just publish it. And so I have my code, I publish it and deploy the contract. I wait for this address, similar to my wallet, and I'm done, all right? I have an address. I also have what's known as an interface or an ABI. It's like any other interface. It describes the contract, all right? But what's happening there is that smart contract, that piece of code exists on the blockchain and can be called whenever you want. If you want the functions to be a little bit more, friendlier than, get my name, what if you wanted to say buy product or, sell product or, get certain bits of information that was, paramount to a group of people, get decisions. And so there's a whole world of being able to store information on the blockchain, and technically we want to be able to get information on the blockchain and stay on the chain. But as we're finding limitations, we're constantly creating technologies to get information off chain in a reliable way and speed things up. And we will cover those two things. I'll do a quick synopsis on side chaining and what are lightning networks for those people that might be concerned about the transaction flow of blockchain, because I said, well, what's the throughput? Once I see this, great. Can I put a mobile app on top of blockchain? You can, all right? And this is exactly the type of solution you would use. You would create the same interfaces, the same API you would possibly on a database, and you would execute it, and you would be able to return the data forever. Now, eventually, they're going to start charging for those old contracts, or put a sunsetting clause to say, hey, if you want to store this longer than a year, maybe you have to pay for it. Right now, you don't. But eventually, they do say this, and I think it's a good practice, that as you're creating these contracts and you're doing it, let's clean them up, let's kill them. And so that would release, obviously, that contract that on the blockchain. If there's any funds associated to a transaction, it gets released, and you're done, and you can't call it again. You would have to redeploy it. Cool. Let's go on to the next. And I think I hit the button. Oh yeah, sorry, gas. There's a little lag. So I talked about this, but when I deploy the contract and when I execute the contract, I have to pay my fair share, and that's called gas. All right, those are the two areas. So the first time I deploy it, I got to pay up front to say, hey, there's a deploy cost, a creational cost. All right. But then it's so much cheaper when I get into executing it because it's there. It's already been deployed, and I can run it at far less. And so I took a quick snapshot to say, well, what's that cost? What is that? And how do we compare it? There you go. There's a wonderful company out there called Ether Gas Station. All right, they look at Ethereum and they dynamically calculate gas. To understand the relationship between gas and gas price, we look at each method invocation, each storage, each action inside of the code has a cost, right? I thought it was too detailed to go, but if you're storing data, it's a cost. If you're going in a method and trying to call stuff off chain or possibly to another contract, there's a cost. So there's this cost of doing business, all right? Some cost more, some cost less. So when I deployed this, it cost about 300,000 gas, all right? And my execution cost was far less, 24,000, all right? So when I wanted to deploy this, if I wanted to deploy it, and I really didn't care about time at all right, it's going to cost me about 4 cents US in their equivalent of an Ethereum. And then if I execute it, it's going to cost me less than a penny. And as you can see, the more I want to pay, all right, in my gas price, speed increases all the way up to $4. Now they are working on slowing this, or actually increasing the bandwidth of the transactions as well as lowering this. It's conceivable that these prices will be 100 times cheaper, maybe even like 10,000 times cheaper in the near future. All right. In the news here, I love this. They're creating a voting machine. I believe this is in Iceland, perhaps. Global news. They're creating a government that uses Bitcoin voting machine. It's a blockchain voting engine. I'll look at the questions at the end. We have a lot to cover, so I will go back. And the gas price is also what miners collect. They're getting this transaction fee for processing these things. They're going to look at it and they're going to process it faster. That's why it gets done. You give them a little bit more and they process it quicker on the stack. All right, I'm going to keep moving here. Intro, we created the history, user knows miners, lifecycle, cost, and we're going to pick up the speed a little bit, trying to give you the same tempo. So, trust, all right? When we talk about value, trust is the biggest value statement you can get out of this, all right? And I have a great example that represents trust. Why is blockchain popular now? I saw this. I thought this was pretty impactful, and so I hope it has the same kind of impact to you. But if we think about where we are, 1400s, we had the guys that basically had printing presses. They controlled what we read, all right? We didn't have a choice. They controlled it. They printed it, and we said, oh, I'm going to read this. All right, we had a manufacturing company, all right? They made a certain type of, engine, and that was the way it was made. And we had to buy it, and we had to put it in all these different systems, all right? In the 1990s, we had online companies. We connected the world and our ability to store information. And this last thing, which I think is pretty powerful, is what's known as a trust company. I don't know if it's going to stick around, but I like it. A trust company is this notion, all right, that we have not had trust the way blockchain is going to give it to us. All right, we've had this facade, this manufactured way of giving us trust, all right? And I'm gonna give you an example, show you exactly how, all right? How much is $100 worth to you, all right, when it comes to trust? Would you buy something from an untrusty environment? Most people wouldn't. I have distinct ways that I buy stuff online through eBay, through Amazon, and it's got to meet my criteria of trust. And what if that went away and you knew you could trust it without having to check the star rating or the transactional percentage of the good or the bad ratings? All right, that's what they're really kind of saying about this trust company, is that they're doing something. And so we're going to use this great example. Everyone loves this. All right, we're going to buy a home. All right, and when anyone's ever buying a house, there's some people that you trust. All right, and so let's go through this. All right. You're a builder, there is a builder, all right, and he's got a half-acre woods, he's got an idea, and he's approved for $500,000 for a half-acre lot inside Boston, all right? It's pretty rare, he found one, cool. What does he do? He goes to an architect, all right, he's going to get charged a little bit, and he builds the house to standards and codes, all right, and he's going to use the contractor, and he's going to use all the guys to build it, and when it's time, they're going to bring it to the inspector, and he's going to look at it, right? And he's going to say, you know what, your house is built to code, everything's good, you now have an occupancy, you can get into the house and, go ahead. Cool. Along comes a buyer. They're going to now buy it for $1.2 million, great heyday for the builder, all right? And so, cool, they're approved. They're going to obviously go to a lawyer, all right? And eventually, we're going to go to the mortgage company, and the new homeowner is now the new homeowner of 33 blockchain estates. Now, I set you up. What you don't know here is in this next slide, all right? The builder has been through 3 bankruptcies. We didn't really know that, The architect is notorious for using shady and non-standard items. He uses people that perhaps aren't legit, and so he's always trying to save money, and so he failed the inspection 2 times. Oh, and the lawyer that we know is under 3 lawsuits. All right, this represents that facade of trust. We didn't even know it. This could have happened all along. Now, how does this change in the new paradigm of blockchain? Well, let's see if I can give you the same kind of wow factor I saw. All right, the builder has a wallet, an address that represents him. We know who exactly he is, and we can represent the house, the interest, the idea of what he's working on. We put that on the blockchain, all right, and encrypt it and secure it. He cannot modify that data. It is permanently recorded, all right, which is wonderful. All right, when the architect comes along, he links to the builder, he links to the house, he links to his address. You can see these nice little hash codes. That's just a pseudo address. They will be changing, all right? And so he links his idea, his standards, his codes to the blockchain, all right? And that first attempt to try to get it passing inspection, it fails. And guess what? The inspector puts the failure on the blockchain, linking it to not only the house, but the architect and the builder, all right? And so now I'm just going to speed it up. It's the same thing, all right? As a result, we now see it took 2 attempts, all right, all recorded on the blockchain, all right? And the inspector's like, yeah, you finally passed. I know, I can trust this. Why? Because I have the complete history, auditability of the entire transaction of that house being built, all right? The buyer comes along, all right? The lawyer comes along, and the builder, all right? And so this is kind of a great way of establishing what I mean by trust centers. We're now recording what happened, all right, from the time of that, creational concept, that digital asset, in this case, the mortgage, the deed, the title. It's all there, and anyone that wants to get access to it has to do it, has to record it. And so I love this little news blurb. Blockchain startup taking on fake news. Imagine we were to say, hey, you know what? If you have news, you have to put your sources somehow on the blockchain, all right? You can't just make it up anymore. That would just disrupt any notion of fake news in the future. And if they stored it in an encrypted way in which, only through maybe the act of Congress or something, they could decrypt it, great. But they wouldn't be able to just fake it, all right? There could be people out to verify that fake news bit. So we could use the same thing there. But let me continue on with this, this home example. Simply time stamping, all right? And I like this concept because it's simple, all right? We saw that Solidity contract. If every builder, lawyer, architect, civil engineer, everyone involved in your house, anyone that worked on it, touched it, used it, simply timestamp the fact that they were there, all right, in a day. I don't care. It's not really. It's not meant to be like I was there for 2 hours today. It's just a day. Just show me that you showed up. And then we'll see the pattern that you were there 28 days in the creation of the house. Simple, right? If we had that, that's the power that this next slide has, all right? Which house would you buy? The one on the left, all right, is the same value on the one on the right. But the one on the right is through my fictitious company called HomeChain, all right? HomeChain has a program saying nobody works on this house or buys product unless it has been timestamped and or put on the HomeChain blockchain or Ethereum blockchain. It really doesn't matter. It just shows you that all of that information is there. And now the homeowner, all right, has all that data. Who exactly painted my house? Who worked on the plumbing? Everything, all right, with the purchase of the house. And so if you've ever bought a new house, it's kind of incumbent. You come to a new area, you don't know who to hire for the plumbing, the painting, and all that stuff. And so now it's all included with the house. Wonderful. Who wouldn't want that, Oh, is there a typo? Maybe. Moving on. So I thought that was a very powerful example of trust and how we can get trust on the blockchain. So moving here, we have security. Security on the blockchain obviously is built into this whole network architecture of peer-to-peer networks. All right, the nodes and the miners add to this layer of security. The reason why we say it's always up or it's more secure is for you to affect the blockchain, you would have to take over the majority of miners and or nodes, all right, in your algorithms. That means they have to have like a 51% stake in the entire network globally. The cost of that is probably not going to want hackers to do it because that could be in the millions and billions of dollars to do it. And so that's why it's more secure. Is because it's so distributed that you can't just penetrate one little area. You can't just get one key and then control everything. It doesn't work like that. Let's see. How do we manage identity? This is that identity play. These are all the identity blockchain solutions out there. All right, and they're all after trying to get you to use them so that way you can go about using the mobile, the browser, or banking in a unique way. And they're storing all your data. All right, and that's the future. I like Showcar because it's mobile. They want to say from a mobile store, you don't have to log into any mobile websites. Obviously, they need me linked to Showcar for that to work, but that'd be nice. I never have to log in. I kind of have that now, but what if some of your, the website data was stored embedded in that, and then I could use that and I could take it over. Blockstack, go on browser plus data and mobile, and then KYC chain. Well, when it comes to banking at the higher levels, you're not going to be able to kind of transfer digital assets very easily without proving who you are or the value of what you are. So KYC, know your customer, and so they have regulations on know your customer. And if you get approved by that particular KYC chain, then you can go and you can maybe trade larger size assets. And so they just need to know who you are. And so there's lots of identity plays over here, and there's a whole bunch. So private access keys, obviously if you lose your key, you lose access to your data. You lose access to the solutions. This is a great little news blurb. Somebody threw away a hard drive, simple file on the hard drive, and he can no longer access the $7.6 million worth of Bitcoin. That's right, he lost $7.6 million cleaning a house. And so you're going to have to set up a technical architecture to store that. If it's just a single case and you're creating just a simple Solidity contract to test it, it's probably not. But what happens when we get into multi-signature? Or are we going to separate, ownership of the transaction? Are we going to separate payment? And all of these have their unique private keys and public password keys. How do they get managed? Who's where in that sort of API and lifecycle are we supplying those those signatures and those access codes? And so that solution needs to be thought out. And so I just kind of touch on that notion that you have to think about your private keys. Uptime, we talked about this briefly. Let's see. You'd be shocked to find out that Bitcoin right now, best I heard, again, this changes very, very quickly, but Bitcoin has like a max throughput right now of like 10 transactions a second, which isn't much. Ethereum, about 15, maybe 11. I hear it being debated. And so for those to reach into the hundreds of thousands of transactions a second, we need to start thinking of new ways of leveraging blockchain and creating two types of improvements, all right? So you always have the primary blockchain, all right? But then there's a notion of side chaining, which is embedding another blockchain to the side to hopefully give us this throughput, all right? And so that's simply just taking some of the noise that we don't care about, putting it on the side chain, and keeping the primary chain as fast and lean and mean, all right? Lightning Network, very similar, but without getting overly complex, they do it in a temporary channel, all right? And so I'm not 100% convinced there. There's different implementations that are going on. There's a Bitcoin style and an Ethereum style, but just watch out because the Lightning networks, while fast, they aren't persisting everything on the blockchain. So that auditability, that history, if you really want all of that, just double check to make sure that they store all the information. Lightning networks are fast, but they're not necessarily giving that complete history and auditability that you might want. So. Let's see, we are going from disruption. We are going to disrupt the market here. You can start with the knowledge centers, those proof of concept teams. So inside of your entire organization, create a proof of concept. I encourage you, figure out where the gaps are. Where's the knowledge lacking of, blockchain? Do we have any low-hanging fruit? I have an example right after this that you're gonna love. And I think being a certified enterprise architect, I think partnering with business architecture, understanding your business processes, seeing which ones perhaps can be identified for blockchain enablement may exist. And I have a great example for that. I think this is the next slide right here. And this is one of the key things. Think atomic. Assets, trust, ownership, money, identity, and contracts. All right? So what do I mean by that? Here's just I think this was a flow, a swim lane that I pulled off the internet, all right? And it just represents something that I think every company has. It's a payroll, human services. All right, cool. We get past that, we start looking at this, and if I'm just start thinking atomic, very quickly, mind you, this is a very simplified approach, but if you start thinking atomic and we start following this thing and I start thinking what letter comes over here, the first thing in this flow here, all right, I see enter correct personal information. If I have licked identity when it comes to the blockchain, correct information seems to be irrelevant, all right? We don't really have that problem anymore because we're managing our identity, all right? And so the only way that would ever go wrong is in the exception case, and I think it'd be less. So we really don't have that. We could solve that maybe with an identity play. The next one here is review and approve as needed. Well, somebody simply doesn't trust the process, And so if everyone's managing their identity and contracts are hardened, perhaps we can eliminate that need for a review and approval process because we can associate trust, to where the concerns are. So what are the big concerns? What is it that they're needing to do there? Can we set that up in a smart contract? And so I'm going to spin it over here. We got ownership problems, someone wanting yet again complete review of this whole process. So just setting up another stopping point. All right, so I'm just going to show you simply, the key words in each one of these blocks is what set me up to say, is there a automation, a contract, a smart contract way of doing it? What is the ownership concern here? Do we really need to stop that, or are we required for hitting go? An ownership kind of methodology is setting up a contract with a button saying I approve, and so we can still have that. But maybe we can put all that information together and just make this whole process work on one button. And then that one button approves it and also releases the payment. And so that's where you might be able to embed or at least have the discussions of blockchain. Is it that simple in practice? Not so much. But I do believe having the conversation is what needs to happen. And having the conversation is difficult because not everyone's ready to go jump into a blockchain solution when it's already working. And so you have to have a value prop. What is out of this, the same that we enable all this, what is the value? Is the value that we've had misappropriated funds, as a value that people aren't getting paid? Can we eliminate that? And so now we have that value prop. All right, value recap, cool. We're gonna speed it up. I've given you a very good description of all this, and we're gonna go into maturity. So now we're hopping into the area of risks. Where is blockchain maturity? It's right between machine learning and commercial drones. Still says it's about 2 to 5 years out, but to get a piece of that $10 trillion worth of funds, you're gonna have to be a little bit more adventurous, all right? I think some of the concerns of this maturity are banking ICOs, this initial coin offering and exchanges. I think this is kind of like that area of where we're getting this maturity. We have maturity on transactions and being able to trade coins and all that stuff, but do we have maturity on infrastructure plays and creating business enablement, all right? There's a lot of people trying to get to that level, all right? And as we go into the next major, talent. Finding these people, finding the coders and whatnot. I think this is a great slide. I'll try to take a little time on this one because I think this is a good, when you need to hire and get people, I still think the best course of action is to start with business architecture and maybe smarten up a business analyst with blockchain. Start giving them the definitions of blockchain and how to identify it. Have them be atomic and use patterns as ways of solving it inside your organization. And once you have that, maybe we now have the business processes, all right, are the identified ones. And if you have never done it, I love doing this with executive boards and everything. It's a should-could framework. It's simplified, all right? But once we have that identification process, we need to know which one should we work on and which one could we work on. And as we can see, the should is on this kind of vertical over here, and the could is on the right. We need to find one that works. And the extreme examples is, should we have robot workers? Possibly. Could we? Probably not. It's cost effective. It's not there yet. Could we put chips in our employees, right now and get atomic people working for us? Yeah, but should we? And so those are the extremes of like using the should-could model. I think this is a great way because beyond just getting the bubble, what you get from a should-could model is the intersection of what leaders, managers, architects, and directors all see as indecisive value, where the disagreements lie in value prop. And so what does that mean? That means the executive team might see huge value in something, but the development team doesn't. Or the management team loves the idea, but no one else supports them from a development to a leadership standpoint. And so we can get through those noise, those areas, those roadblocks before we even go on to the opportunity and getting the resources allocated. And so it's a great way to establish a good identification of what is a good opportunity. Oh, I'm going to go back. If you didn't see it, when I ran out and I wanted to say, hey, if you want to get some developers, I saw this, and I didn't believe it, but apparently it's right now. one of the biggest, hottest thing is a blockchain developer, $200,000 a year. I think that was just a generic statement. It's just getting hotter and hotter because there aren't too many of them. All right, moving on here. We got 5 minutes left. I'm talking. When we talk to shareholders, we have to cover the technology, where the maturity is, both from a blockchain perspective, but how we can integrate with blockchain on our previous technology stack. Do we have the enterprise reference model at a mature state to integrate? You know, from our business, do we have digitalized assets? Can we represent a digital asset online? You know, from an educational standpoint, how are we going to change everyone's view on blockchain? Is it necessary? Can we manage blockchain in a way where no one has to necessarily get to the technical side, and so it's a hidden way of dealing with the problems. So cover that. I'm going through the slides right now because I'm seeing the time. I'm a huge talker, and I think I might have focused on some of the other things. So I want to give you guys the value. What are typical concerns with, you know, the government interference? They're not going to really interfere. They've proven themselves year over year. They didn't interfere early on with .com. All right, they interrupted when people were embezzling and stealing funds, and that's the same thing they're going to do. You're going to see the government interact when people are bending the system. All right, and because blockchain and money go hand in hand, there's two sides to the equation there. We can have blockchain and we can have infrastructure, but when we have blockchain and we have people pumping and dumping ICOs to make millions of dollars and then run away, government's going to step in, all right? And there are some really good examples of powerful ICOs, people that raise money very quickly, all right, collecting money, all right? And so it's unclear, you know, I think, where the standards are. And so one of the biggest concerns I hear from boards is like, well, if we don't have a clear roadmap of the standards, we're going to waste our investment. I don't think that's accurate. I think you're going to learn knowledge. You're going to learn, you know, the risk. You're going to learn how to identify the opportunities. And when the next technology comes along, or by the time you're there, the technology that's there, it's going to be the right time for you. You know, how do we tax? How do we report this stuff? All I can say is that the IRS is onto blockchain, and they are auditing blockchain through and through. And so while it is anonymous and while it is there, they're going to have a history of it just like everyone else. And so don't cheat, don't hide money when it comes to blockchain. And that involves doing trades online and everything else because they're getting very smart. Okay, risk recap. We talked about maturity, we talked about the talent shortage. We talked shareholders, gave you a list of things we're going to talk about, and the regulatory concerns. We're going to kind of finish up future, and I'm going to get to as many questions as I can. All right, I'm going to have you guys look at this tech stack offline. All right, these are the two best ones. What you have on the left, all right, is from the Cloud Council. They did a wonderful job. I encourage you to sign up. It's a great way of looking at blockchain as a decomposed layer of services or components or capabilities. And this is how blockchain's probably going to mature. We're just going to embed blockchain as a service to different areas of the organization, all right? And so they have the identity bucket and how you're managing it. They even have the consensus protocol and how you might want to use your own, you know, and you might have private blockchain inside your organization. Off to the right, what we have is a private one, all right? And this is through Hyperledger. And Hyperledger is very mature, and there's lots of great examples of people using Hyperledger. Hyperledger is completely private, you know, that's the whole notion. So I gave you a public side and a private side, but both are segmenting their service and capabilities across blockchain in different buckets. And I think how that intersections to your enterprise reference model is key. And so there's some example that needs to happen there. So just I'm just zipping through it because we got it. We talked about trust centers. In the future, trust centers like Amazon, Airbnb, and Yelp, they have predominantly profited just because they're a place we trust. If trust goes away, so does their value prop. Trust just becomes something you can find, something you can identify, all right? And so I have this great example, all right? With 2 minutes left, I'm going to do it. I'm going to try to run down all the questions. I know we have a lot. It's the pizza store, all right? How does a simple pizza store get benefit from the blockchain, all right? Well, we got the cost of doing business. It's about $5.10 for a pizza, right? And so when it kind of looks, that particular person, that owner of the pizza joint, he talks to all his vendors when he moves in, and he sets up these long-term relationships, all right? And so he's probably never going to call those vendors again, all right? And so he's kind of an incumbent. He's there. He's just staying status quo. If he were to jump ship, someone might try to say, oh, you know, well, you're new, and so I'm going to charge you more. Well, the blockchain and its ability to use contracts to both buy, sell, move, transport can eliminate a lot of the waste that's going on. Those smart contracts can be an automated way of buying, shipping, selling, transporting, everything. And so if we were to just like look at this, he could make a lot more money. The farmer could make more money. And so here's just a typical, you know, supply chain. The farmer who has the flour, you know, the cheese or whatever it is, all right? And it's just, you know, just to kind of get you the idea. All right, he goes through layers of people, part of that supply chain. When it comes to something like the fair trade certificate, in a fully trust world on the blockchain, that goes away, as well as many of other middlemen, all right? And so they're not taking their rip anymore, and so the farmer can make more money, and the buyer, in this case, the Gorman Pizza House, can buy things and less money. And so I hope this is like hitting you and how impactful blockchain is. And so now I'm going to open the floor and try to answer some questions. And if I have to go back to some slides, I will. And so we put the slide number, slide 9, decentralized versus distributed, refer to the fact that the data is spread across. Yes. David, you nailed it. That's exactly what it means. Slide 13, everything seems to be around hashing. Has anything been done with miners where they validate something visually? Yeah, so Daniel, I didn't want to focus on mining. I own a mining farm, and I can definitely go offline on that, exactly what they're doing. I run OCR on that, and the result is what the OCR returned. So I'm trying to get through all the questions. I'll look at the OCR. Dead or should be deed? Oh, I'm looking, there might be a typo here. And how are traditional finance service companies competing in technology? What can they? So I apologize, but Ijaz Osman, your question, yeah, there's a lot of disruption when it comes to financial institutions. And I think there's a disruption that's coming, and they're seeing it. Eventually, you will be able to move, transport money in the same way that you're using a credit card in the near future. And so the value prop of a Visa, of a Bank of America is less, all right? So they're going to have to maintain their value to keep you, all right? And so I'm going to go back. Let's see if I can go back to slide 1. Because we were short on time, and I'm obviously a talker, for those people still online, I'll go back to this slide. Down below, if for some reason you have a question, well, not sure what happened there, slide 3. There you go. On my LinkedIn profile is something called Time Trade. If you have a question, because this is complex, I tried to cram 2 weeks worth of blockchain. You're going to have to read the PDF when it gets to you. If you have a question, feel free to just go there and take 15 minutes of my time, and I'll be happy to try to get you that in-depth answer you're looking for. So when it comes to mining and you want to know it, sure. When it comes to you know, Solidity or other questions of how to test it, how to deploy it, we can talk. And so all of that is on the table. Oh, I'm seeing more questions now. Wonderful. Thanks, guys. Going to go back to the last slide. Well, I'll just leave it where it is. Okay, so we're going, could you post the presentation link? It'll be emailed out. I don't actually have the link. Instead of the future of digital currencies, so we're just being stuck with a huge bubble. Yeah, Tom, in the it's micro font, so I apologize, guys, when I'm reading this. Yeah, so Tom, I agree. There is a bubble. So we could talk about the bubble very quickly. You know, Bitcoin, who was first, the incumbent blockchain leader, they're, you know, saving on for dear life, forking and trying to reorganize the blockchain so that way it's more performant. If they don't, it will die. It will be too big. I don't know if anyone knows this, but the nodes that we talked about, I believe it's something like 60 gigs and growing. Every transaction ever on the blockchain is stored there. And so until they can figure out a way, all right, to solve the increase in data and slow transaction throughput, and just the bottlenecks that exist, you're going to have a problem for blockchain, because you roll it out 5 years, that file is no longer 60 gigs. It's growing at a terabyte a day, or there's some math that shows that, and that's where you lose your distributed nature. And so there's definitely some concerns there. We weren't able to look at miners in the same view, but mining pools offer a similar concern, where we want this distributed notion. But we're not quite getting it, because mining pools have, owned, eventually maybe there's only going to be 10 mining pools for Bitcoin, and, maybe the same for Ethereum. And so we get concerns. No, it's not risky to lose your key, Sean son. No, it's not risky at all. You can store it anywhere. It's just a file. Think of it as a JSON file. It's remembering the password. That's the hardest part for me, if you have too many of them. Why did China pull out? Oh, great question, Daniel. Yeah, the ICOs. I am a believer that China stopped ICOs because of the bad actors. There was a lot of pump and dumps. For not too much time and not too much energy, you could go put an ICO on the market and get funding. Imagine I created a startup and I was putting it on NASDAQ within a week. All right, and then trading. It just seems awful that you can do that. And so China had obviously found that there were some concerns and people, playing with ICOs. And when, 80 out of the 100 are bad and they basically go away, it deters other investors from investing it. And so I think that the ICO that is being banned from China is because they want a very more rigorous ICO process, all right, before you're allowed to invest in them. That's it, just because they're big. Any comments on Jamie's slam Bitcoin fraud? I would talk for a ton, so VJ, yeah. Interesting look, David. Thanks, guys. So honestly, there's a lot here. I encourage you all to look it over again. I appreciate everyone online, appreciate the questions. And we will be following up maybe with a more in-depth area if you guys show the feedback to WebAge. So I'm going to end it. We went 7 minutes over, so I appreciate everyone's time. Again, if you get a question from me, feel free to send it on an email or just create 15 minutes with me and maybe I can show you a visual. Cool. All I can say, just ping me. That's all I can say. Or write a question to WebAge. They're going to follow up with an email. So I'm going to end it. Any other questions? Alex, you online? You want to cover any housekeeping? Cool. All right. Thanks for the feedback, guys.
All good, Corey.
Cool.